Hello, we are going to, for this assignment, perform a quadratic regression using a graphing calculator. Again, what we've got, this assignment is going to look very familiar to the assignment we did before, where we used Desmos to enter in the data in here and create a model that would, or a function, a quadratic function that will model the data here and allow us to figure out the path of the ball so that we can answer questions about it. So again, you may want to read the scenario, but basically you have an amount of time, there we go, and based upon the time that the ball is launched from a cannon, it goes a certain height and then it comes back down, and our goal, our job is to figure out, how high the ball is or how long it takes to get to a certain point. And what we did in Desmos is it was pretty easy. We would enter in this data here, if you remember, and then we would use a command to basically get the quadratic function that modeled that data. And then we could click on different parts of that function. But today we're going to use a graphing calculator. So I'm going to show you the step, and this is what we're going to do on the test. We can't use Desmos, but I'm going to show you the steps where you enter in this data, and then you can start to answer questions about the path of a ball, or the cannonball, I guess is what it is, right? That was launched from a small cannon. You can start to answer questions. So step number one, get a graphing calculator. And I'm going to show my on-screen one here real quick. Okay, so again, this is my on-screen version if you've got a calculator. So now we've got to enter in the data. Let's go back to that screen that we have over here. The data from this table right here. Why isn't this drawing? Okay, let's see. Oops, there it is. Okay, there's. So you need the data from that table into the calculator. So we've done this before with linear regressions, so this should be something that's very familiar. But if you remember, you go to Stat, and you go to 1, and then you hit Enter. It's already on 1. And if you remember, you have to clear out the columns using your arrow keys, and you hit Clear and Enter, and it clears out the whole column. You go to this one as well, clear and enter, and now you can enter in the data. Okay, so again, what data is that? The data from the table. So the first one has 5, 10, 25, 30. I'll enter that in, 5, 10, 25, 30, and then the next table. Okay, so I entered in the data over here for the second one, which is going to represent the height of the ball at various times. Okay, so make sure you enter that in. You don't need to enter in a comma for these numbers. Just enter it in as is. Okay, so now that we got the data entered in, now we're going to run the regression. Now we're going to go to Stat, use the arrow key to go to Calc, and then we're looking for, in the past we did a linear regression, but if you can look at number 5, this is a quadratic regression. That's the kind of regression you run on data that has a pattern that looks like it could be fit or modeled by a quadratic parabola. So that's number 5. So I can either scroll down like this or type in 5, and I hit enter. Where's my enter button? Down there. And then we scroll down until we get to calculate. Hit enter again, and voila, check it out. This is what we've got. We've got an equation here. Now, this is the important thing to remember. A quadratic equation, the generic standard quadratic equation is a times x squared plus bx plus c. So the a, b, and c are what you call parameters of the equation, and the x squared, or the x and the y, are the variables. So based upon a given value of x, we plug it in the equation, we're going to get a value of y. Well, we're not going to get a value unless we have values for the parameters, the a, b, and c. So the a, we're told right here that these are the values. The a is -3, the b is 126, the c is 5. So that also allows us to answer questions on the handout. So I'll go back to the handout real quick. Okay, so here is the second part after we did the regression. So the A, B, and C here come directly from the A, B, and C we had from the calculator output. Where'd that go? There we go. Okay, so the A, B, and C right here are going to be the values that we are going to enter in. So the first one was what? It was, let me get so it was negative, this is very annoying, -3. B was 126 and C was 5. So 126 and 5. Now, what does that mean the actual equation is? Well, the actual equation, we're going to need this, is y is equal to, remember, here's a generic equation. And the specific one, in this case, a comes from up here. So it's going to be -3x squared. We're going to use this in a bit, plus 126x plus 5, okay? Now, how do we use this? At what height was the ball launched? Well, remember, that is going to be what this value right here, which is the y-intercept. When x is 0, if we were to plug in 0 right here, all we would have is these would zero out, and you would have a plus 5. So the ball is launched at 5. So it's the same value as C. When did it hit the ground is another question. So I'm going to show you how we can get through that. When did it reach the maximum height? That's another question. What was that maximum height? And when did it reach 660? What was the height after following number second? So these here, I'm going to put in a different video, okay? This is just going to be questions. So questions through 13 are going to be on this video here that you just got done watching. And then I'm going to show you how to do questions 14 through 18 on the second video.